Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Go programming language. So let's look at today's question, increasing triplet sequence. Given an integer array nums, return true if there exists a triple of indices I, j, k such that I is less than j is less than k and nums of I is less than nums of j is less than nums of k. If no such indices exist, return false. So basically, given an array like this, we need to find a triplet where which follows this order. Nums of I is less than nums of j is less than nums of k. Can we find the order like that here? I, j, k. So yeah, so this itself can be our order because 3 is greater than 2 is greater than 1. Or here there are multiple examples. You can even move it here. 4 is greater than 3 is greater than 2, or even you can move it here. 5 is greater than 4 is greater than 3. So this is obviously true. One interesting example is if you take something like this. No matter what you take as I, right? You'll never be able to find anything that follows that sequence because this array is in a complete decreasing order. So no matter what we do, we will never find a sequence like this in an example like this where the array is in decreasing order. So that's one of the observations you can make. Given that, how do we solve this? And what's the most brute force way of solving this? So the most brute force way of solving this is to just use 3 loops, right? So where I goes from 0 to n, j goes from I plus 1 to n, and k goes from j plus 1 to n. So using this, you can just try to find 3 indices I, j, k which are in this order. If it's not present, you can just return false. The issue is this is O of n cube. So the problem, if you see the follow-up, they expect us to solve it in O of n time and O of n space. So this will not work. So what can we do? Is there a way can we to do it in O of n? So let's try to understand intuitively what can be done here. So if an array is given like this, right? Essentially you need to find 3 elements which follows this pattern, and the 3 elements will be such that one will be smallest, second one will be second smallest, and third will be greater than these 2 elements. So if you basically if you consider first and second and third as the 3 elements of the triplets that we need to find, third has to be greater than second and second has to be greater than first. So can we do it in a way that you can do this in one pass? So I think greedily what we can do is try to find the smallest element first. So, and we can call it first. Okay. Try to find the smallest element and you can call it as first. After you have found the smallest element, try to find the second smallest and call it second. So if you have found all these two numbers, and and after that, if you get a number which is greater than these two, that means you've already found the triplet. So how can we try to achieve this in single pass in a code? I will explain it to you. So let's have two numbers, first and second, both initially being infinity. So go through your nums, which is I. So is 1 lesser than first? Yes. So update first as 1, and then go to second element, which is 2. Is 2 lesser than first? No. Is 2 lesser than second? Yes. You found your second smallest element. Now you come here to 3. Is 3 lesser than 1? No. Is 3 lesser than 2? No. So if 3 is not lesser than 1 and 3 is not lesser than 2, that means 3 is greater than first and second. That means we already found our triplet. I hope you guys understood the logic here. The thing is, 3 is not lesser than 1, 3 is not lesser than 2, which means 3 is greater than both of them, which is exactly what they are asking here. So that's why we return to true. So this is exactly the logic that I'll be following. I think when I code it up, you will understand it in a much better manner. First, okay, let me just define the steps: initialization, and then looping logic, and then this return. So initialization will be first, second, math dot so this is exactly how we will declare mag infinity. So this is basically like defining infinity. Math dot maxint basically means maximum infinity. And then let's find the looping. Let's do the co-looping. That's fine. Let's do it. For comma range. So this is also one of the ways in which you can write loop in Go. So I have written loops in different variations in my YouTube channel. So I'm just showing you a new variant today. So yeah, we have done this, and then if num is lesser than or equal to first is equal to num, and then else if num is lesser than or equal to second is equal to num, else just return true. And also in Go you can't give space and write a else like this. It needs to be formatted like this, otherwise it throws an error. So that's one more thing you need to understand. If you can't, what I mean is you can't put a else like this, it's an error. You need to write it like this. And then if not, you return false. Okay, let's check this. Yeah, 100% runtime. But yeah, there is one more logical thing that I wanted to explain here. Why are we doing lesser than or equal? Why not just lesser? That's an important question for you to ask yourself. Why are we doing lesser than or equal? Because if assume you have an array like this, 1 1 2 5 or 3. So in this case, if you just put lesser, then first will become 1 here, second will become 1, because if it was lesser, it will go to the second condition and make second equal to 1. And then we'll have first and second both equal to 1, but the conditions are such that the second should be greater than 1. So that's why we need lesser than or equal to, so that even if a duplicate number comes, see here, even here, even if 1 comes again, first only will be updated as 1, it won't go to second. So that way this order will be maintained. So understanding why it is less than or equal to instead of lesser than is very important in this problem. Other than that, let's just analyze the time complexity, which is fairly straightforward in this case. O of n, because there is just one loop and we are not using any extra space here. So time complexity of n, space complexity of O of 1, which is the most optimal way of solving this. We also got 100% runtime. Thank you so much for watching my YouTube video.